Hi everybody, welcome to the next session or the next topic. Last sessions we have learned about electric field due to continuous charge distribution. In this session also we are continuing the same thing, electric field due to continuous charge distribution. Last class we have seen two cases. One is due to the electric field produced by a conductor and along its same lines, okay, and that is the first subtopic. And the second subtopics we have seen, electric field will be created by a semicircular ring. It is just a wire. First case also it is a wire, second case also it is a wire, but the difference in the second case is like in the second case it is a bending, so a wire which will have some bend and it's in the form of a semicircle. So today we are going to see the next part will be here. Okay, so write on the next subheading, the continuation of the previous session only, the third subsection, electric field due to quarter circle, electric field due to quarter circle in the sense quarter circle wire. Okay, so we'll draw the diagram as like what we have doing in the normally. So this is a quarter circle. So this circle, this means it's a wire which is in the form of a quarter circle, and this wire consists of charges, positive charges. Okay, so the wire will produce an electric field. So electric fields are away from the conductor, not towards the conductor, okay, because it's a positive charge. So we have to give the electric field lines at this point. If I am considering this point, then we are taking a small strip of conductors will be here, and this will produce an electric field will be like this, and this angle I am giving as theta. So this will produce, this is a small current element, a piece of wire, and whose length is dl, and it consists of a charge called dq, and this produces an electric field will be here in this direction, which is called dE. Okay, if this angle is cos theta, then this angle is also theta. So this dE we cannot solve it, as like I told in the previous sessions, we cannot solve it, right? So what we will do, we have to resolve this dE, because whatever coming in the x direction, whatever coming in the y direction is easy for us to solve. But this is not on x axis, not on the y axis, so it's difficult to solve. So we are splitting this one. The dE component nearer to theta side, this is called what? dE cos theta. This is a dE component opposite to cos theta, the other perpendicular component, it's called dE sin theta. Okay, and this is a small current element. So the small current element, the angle of this current element is considering as d phi, and the radius will be equal to r, small letter r or capital letter R, whatever you can mark it will be here. Now we are going to find out the electric field due to a quarter circle. What is electric field at this point? This is what. So whatever we have done for the last session also, for this semicircle also the same thing, but in semicircle what is the difference between the semicircle and this quarter circle, we have to connect. In semicircles the only difference is, in semicircle the difference is like we are finding an electric field due to one current element like this, then this angle is theta, we are writing cos theta, and we are writing sin theta will be here. And if you are considering the same another current element opposite to this side exactly, because this will have some symmetry, right? So if I am considering one element will be here, this will consist of dE, and if this angle is theta, then this angle is also theta. This will give rise to dE cos theta, and this will give rise to dE sin theta. Here also similar to this one, this is a symmetrical structure. So this will also give rise to dE, and this angle is theta, this angle is theta, and this is called dE cos theta, the component nearer to theta dE cos theta, and another one is dE sin theta. There we discussed this cos theta components will get cancelled it out, and sin theta components will get added up, so we are integrated dE sin theta. Here there is a possibility of cancellation. I am just connecting whatever we have learned in the last sessions with this one. So here there is a cancellation possibilities are there because it's a symmetrical structure, but this is not a symmetrical structure. So the x component and the y component, here x component will cancel, y component will get added up. But in case of a quarter circle, x component is not cancels with any of other x component, and y component is also exist. So which means in short I can say I have a x component, I have a y component. So I have two electric fields will be here, two electric field vectors will be there. One is in the x direction and another one is in the y direction. It's not only one. In this case we have only one, right? In this case we told the electric field intensity in this case will be, it's along the y axis, along the downside. But here it is not like that. There are x will be here, there are y will be there. So I just connected between these two for the easy understandability. Now we'll move with the derivations, how this is going to happen. Okay. So we are here. So I told we have x. So x electric field will be equal to, how will say, dE is the electric field created by dq. So if you have many dqs, then we have many dEs, and all the dEs will form raised to x component of electric field. So x component of electric field integral. So where is the integration for a quarter circle? 0 to 90 degrees. So I can say 0 to pi by 2 into dE into cos theta. dE into cos theta. We have to written an equations for dE. So integral 0 to pi. What is dE? K into dq divided by, from dq to here, distance is called r into cos theta. This is a current element. This is a wire. So this is related with one quantity. Last sessions I told. It's called linear density. Okay. Linear charge density. Linear charge density. Linear charge density lambda will be equal to general expression charge divided by length. So if it is a small element dl and small charge is called dq. Okay, so we are writing lambda will be equal to small charge by small length. This is for bigger charge, bigger length. This is for smaller charge, smaller length. So from this one we will get dq. dq will be equal to lambda into dl. dl is for this quarter circle, dl is nothing but arc length. If you are zooming out this area, then this will look like this one. So this is called dl, this is called d phi, and this is called radius. Okay, so we know the basic mathematical principle from here. Angle equal to arc length divided by radius. What is angle will be here? D phi. What is arc length? dl. What is r? Radius. So dl equal to r d phi. We are substituting this stuffs will be here. So now we will get dq equal to lambda into r times of d phi. Okay. This is what we have done in the previously also, and here also we are doing the same steps, same methods. But according to the structure, the logic, the logic will be getting varied because x and y component of electric field will be there. First we started with x component. So we know now dq, we are substituting will be here. We are continuing. So integral 0 to pi k dqr. So k into dq lambda r into d phi whole divided by r. Here one mistakes I made. dE means electric field intensity. K into dq by r square. Square is missing, so I added square. So that square will be also will be there in the denominator. Square, correct? K into q divided by r square. So square lambda r d phi. And in the numerator side it is called cos theta. Here this angle is d phi, means d phi is varying from here to here. So instead of this given as theta, I can say total angle is phi, because phi is a total angle and the small angle is d phi. So theta, now I replaced with the phi. Theta and phi are both are actually same. The only difference is, like, if I am writing theta, then I have to write d theta will be here. If I am writing phi, then I have to write d phi will be here. So here I have written d phi, so I have changed this to phi. So now the limitation of phi will be 0 to 90 degree. So this theta term here I am marking as phi. So cos phi, and here also cos phi, because we are playing with the d phi. So all the small element of total phi is called d phi. Else we can go with the theta and d theta, and anything it will be fine. So integral, what are the things will be constant? We'll take it out of the integration. R square and r will get cancelled. So k lambda divided by r is constant, which will come out of the integrations, and 0 to pi into cos phi into d phi. Cos phi into d phi, we have to integrate. So k into lambda divided by r into what is cos phi? Integral sin phi. Cos phi integral sin phi. Integral 0 to pi. Limitation 0 to pi. So cos phi integral sin pi 0 to pi by 2. It's quarter circle, right? 0 to pi by 2. 0 to pi by 2. So 0 to pi by 2. So k lambda divided by r into sin phi. Sin phi means sin pi by 2 minus of sin of 0. Sin 0 is 0, sin pi by 2 is 1. So answer is k lambda divided by r. This is the electric field created at this point. Only the x component. Only this is the x component. So k lambda by r is nothing but ex. So this is equal to nothing but, which is equal to ex, which means the electric field created by the quarter circle along the x direction. Here in this case, what is the x component? It is along the x-axis. What x-axis? Negative x-axis. Negative x-axis means minus I component. Okay, I, j, k you are learning. I, x, j, y axis, k, z axis. So positive I means positive x. Negative I means negative x. So this is in negative x direction. So in this equations, ex equations, k lambda by r, this is on negative y direction. Next, what is the next steps? We find out ex, but we need to find out ey also. So we are going to do for ey will be also will be here ey. So ex will be there, ey will be there. So hope you got ex. Now we are going to do the steps for ey. So what is ey will come? Okay, ey part writing here. So ey will be equal to, what is will be the steps? Same steps, 0 to pi by 2. 0 to pi by 2. de cos phi. Instead of de cos phi, what will come? de sin phi will come. Instead of de cos phi, de sin phi will come. Next one, de, the same equation, there is no difference for de. What we got finally for de? This is what we got finally for de, right? The same steps. So here we are solved and we got de will be there. Here de cos phi. So if you connected these two, you can say except cos phi, everything is d phi. Everything is de. So we are I'm just substituting in these steps also will be here. So this is integral 0 to pi by 2. de. De means substituting will be there. K lambda, numerator, denominator, r will get cancelled. So r into, instead of cos phi, what is will be here? Sin phi and d phi. Sin phi into d phi. That's all. Now we have to integrate this one. So we'll continue, will be here. Here what are the things will be constant? K lambda by r is constant. Okay, what is the integral of sin phi? Integral of sin phi is minus cos phi. Correct? So minus cos phi. So we are writing the balance steps will be here. So k lambda divided by r is constant and sin phi integral minus cos phi. We'll make a demarcations line not to confuse the other one with this one. So k lambda by r minus cos phi, integration limit is 0 to pi by 2. We'll apply a upper limit minus lower limit. So k lambda by r same, k lambda by r. This minus I take it out for easy understandability. Minus, what is cos pi by 2? Cos pi by 2 is 0 and minus cos 0, minus cos 0, cos 0 means 1. So this minus 1 with this minus will become plus. So k lambda by r, this is nothing but what? Called Ey. Now we got two equations, one for Ex and one for Ey. This is for Ex and this is for Ey. I highlighted both. So both equations are same, which means I have a net electric field on the x direction, on the minus x direction. I have a net electric field on the negative y direction. So which means two electric fields are there in two different directions. How will find out the resultant of two electric field or resultant of any two vectors? If I have a vector, if I have a b vector, then how should I find the resultant? R equal to root of a square plus b square plus 2ab cos theta. Same logic. The same logic, same concept which we are going to apply will be here. So the net electric field will be equal to root of Ex square plus Ey square. Okay. So I'll clear this part. Then I am going to write the next area, which means I have the total electric field E equal to root of Ex square plus Ey square plus Ey square plus 2Ex into Ey into what is the angle between Ex and Ey. This is called Ex. This is called Ey. What is the angle between Ex and Ey? 90 degree. So it become cos of 90. So Ex square plus Ey square. Ex will be there, Ey will be there. Both are same. So if once you solve this one, what you will get? 2 times of Ex. So 2 root 2 will come. So k lambda divided by r. This is the total electric field created by a quarter circle. It's very important. What is the value of k? Last class also, previous class also I told. What is the value of lambda? Lambda equal to 1 by 4 by epsilon 0. Lambda is, sorry, k is equal to 1 by 4 by epsilon 0. Lambda is called linear charge density. What is the value of lambda in this case? Lambda equal to charge by length. Charge by length. What is the length of this quarter circle? For a full circle, length will be equal to 2 pi r. Okay, 2 pi r. For a half circle, length will be equal to half of this one divided by 2 pi r. For a quarter circle like this, for a quarter circle, L will be equal to half circle na half. So again it is pi r divided by 2. So here lambda equal to pi r divided by 2. In case of a half circle, q by pi r. Okay, last class we have learned lambda equal to q by pi r. In case of a quarter circle, length become pi r divided by 2. So remember this equations as a short summary of this topic. We'll move to the next topic. Okay, next topic means the fourth subtopic. So far we have learned about 3 topics. One is a straight road, and we are finding the electric field. If this is a straight road, we are finding electric field will be here. And the second one is semicircle. The third one quarter circle, and we are moving to the fourth one, electric field due to an arc. Arc in the sense it may be, it is not a full circle, it's not a half circle, it's not a quarter circle, it's just a portion of a circle. That is simply called an arc. So as the normal way, we'll start with the diagram. So we have an arc like this. Okay, here to make the calculations easier, we are assuming this is symmetrical about the y-axis. This arc I have placed symmetrical about the y-axis, and the total angle for this arc is called alpha. For the total angle is called alpha. Now what we'll do, we are assuming arc means it is, this is a wire and which is carrying a charges of plus. So the electric fields are away from that one. Now we are going to find out will be here electric field. So if you are taking one sessions will be here, electric field will be like this, and this angle will be there, and this angle is considered as phi. Okay, and here it is the total angle is alpha. So alpha is a straight one, so right side and left side, so two parts will be there. So you can consider from one point to another point. Okay, so alpha left side, alpha right side. So the left side to the alpha, left side to the alpha and right side to the alpha. So left side minus alpha by 2, right side plus alpha by 2. Okay, so which means this is like this. So here whatever the angle I am taking towards left is negative, whatever the angle I am taking towards right is positive. That's all, because of the symmetrical structure. So this is actually ranging from 0 to alpha. Total value is alpha degree. So minus alpha by 2 to plus alpha by 2, which means 0 to alpha. Okay, so because of the symmetrical structures, we are making this to be an half. As like we are normally doing, we are taking a small segment will be here, a small segment is taking, and the small segment will have an angle of d phi and the radius is r, and this is a charge of dq and whose length is called dl. Okay, so we'll start with this one. This angle is called phi a, and this phi, and this is d phi, and the total angle will be equal to minus alpha by 2 to plus alpha by 2. We are extending. If this is phi, means this is also phi. So this angle will be, this is nothing but electric field dE. So this will be comes with the dE cos phi, and the other side will be coming with the dE sin phi. Okay, so dE cos phi, and we have a dE sin phi is also there. So this is purely a symmetrical structures. So similar to this dq dl will be here, I can also consider another dq dl will be here. So this will also create an electric field like this, which will also produce us dE sin phi, and this will also produce us dE cos phi. As like you know, dE sin phi will get cancelled with the dE sin phi because both are in opposite direction and these are the same direction, so this will get added up. So we are going to move forward. So we know dE sin phi will be cancelled, so total electric field will be equal to, cancellations are happening when there is a symmetry. Semicircle cancellation happen because of symmetry. Arc, we put it on y axis and we have a symmetry, so that will also get, this x component will be getting cancelled. But in case of a quarter circle, there are no symmetry, so we have x component of electric field and y component of electric field. Here nothing like that, because here it's symmetry, so x components are cancelled, only y components are getting added up. So integral, where to where the limit, I am moving from here to here, which means minus alpha by 2 to plus alpha by 2 we are moving. What is this y component? Only y component is exist. So which means dE cos phi. We have to substitute for dE as usual and we have to solve this part. What is dE? So electric field E will be equal to minus alpha by 2 to plus alpha divided by 2. Electric field K into dQ divided by, from here to here distance is r square into cos phi. So what we'll do? Next one, we have to replace with dQ. For replace with the dQ, lambda is equal to dQ divided by dl. So dQ will be equal to lambda into dl. So dl is called arc length. So like previous one, so lambda equal to r into d phi. Arc length is equal to angle into radius. We are substituting these stuffs will be here and we are continuing. Minus alpha by 2 to plus alpha divided by 2. k into dq by r square, k into dq lambda r d phi whole divided by r square into cos of phi. Okay, r get cancelled, common terms take it out of the integration, so k lambda divided by r cos phi d phi. So what is the integration of cos phi? Sin phi. So integration of cos phi is sin phi, and the integration limit minus alpha by 2 to plus alpha by 2. So we are substituting k lambda divided by r sin of alpha divided by 2 minus sin of minus alpha divided by 2. One mathematical basic principles will be there. What is that basic principle? Sin of minus theta equal to minus sin theta. Okay, you have learned sin theta is an odd function. Sin of minus theta equal to minus sin theta. Instead of sin, if cos will come, cos of minus theta equal to cos theta, plus will come for cos. For sin, minus will come. So this minus will come out. So it become how much? Sin alpha by 2 plus sin alpha by 2. So 2 times of sin alpha by 2, which means 2k lambda divided by r into sin of alpha divided by 2. This is the electric field created by an arc. Electric field created by an arc. So because of the symmetrical structure, electric field here got cancels with electric field got here, and this field will get added up, and this is like the normal simplification what we have seen for the sessions B, the subsection B, subsection C, and the same thing in subsections D also. Now we'll see, this is a very generic equations for an arc. Okay, so from this one, hope you have noted down, else please pause the video and complete the notes. Okay, then we'll move forward. So E will be equal to 2k lambda sin alpha divided by 2. Now if I am asking for a semicircle, what is the value of alpha? Alpha equal to 180 degree. For a quarter circle, what is the value of alpha? Alpha equal to 90 degree. So we'll see that also. So we have two things will be there. Semicircle, this is what we have learned sessions B, right? So for a semicircle, what is coming? Alpha will be equal to 180 degree. If you are substituting alpha equal to 180 degree, 180 divided by 2, how much will come? Sin 90. Sin 90 is 1. So for a semicircle, we got electric field will be equal to 2k lambda divided by r. Hope you remember this one, the previous session of the videos. Okay, but in case of a quarter circle, just now we have seen, right? Just for a quarter circle, alpha will be equal to 90 degree. If alpha equal to 90 degree means sin 90 divided by 2. Sin 90 by 2 means sin 45. What's the value of sin 45? 1 by root 2. So which means 2k lambda divided by r into 1 by root 2. These two can be written as root 2 into root 2. Root 2 into root 2 is called 2. So this one root 2 and root 2 will get cancelled. So answer will be root 2k lambda divided by r. This is what we have learned it for quarter circle, and this is what we have learned it for semicircle. So in short, for entrance examinations point of view, if you know what is the electric field created by an arc, for semicircle, for quarter circle, for any value, you can find it out, depends upon the value of alpha given in the question. For semicircle, if you know this equation, for a semicircle, you know I have to put alpha equal to 180 degree. For a quarter circle, if you know these equations, you can put alpha will be equal to 90 degree. But then you have a questions to me, why instead of telling all the stories, sir, you can first itself will be say, okay, for electric field due to an arc, you can start like this one, right? Then why you have teached us section B, section B for semicircle, section B for quarter circle, then you come to arc. Instead of going through the other sessions, you can directly come to an arc and you can teach us this one. Then it's very easy for us to learn. Why you have wasted the time on section B and section C? The answer is like, to understand electric field due to an arc, it is not necessary that you have to learn the previous sessions like section B and section C, but in order to understand the real concept, why or what an electric field will be created by a semicircular arc, by a quarter circle, or by an arc. Now these things you will feel easy if you understood the other two sessions, like electric field will be created by a quarter circle, electric field created by a semicircle. If you are clear with this one, then you will be comfortable with this one, because you know the method which we are used there. That is one reason. Another reason is like, in case of a semicircle, if question is asking for the Neet or the JE examination, what is electric field created by a semicircle, you learn these equations, 2k lambda divided by r sin alpha by 2. You will put alpha will be equal to 180 degree, you will get the answer, you are happy. But in case of if they are asking about the direction, if they are asking about the directions, from this case, it's hard to, okay, from this logic, you know it is on the minus y direction. But based on this logic, it's hard to predict for a quarter circle what will be the direction of electric field. You can, from this one, we have cancelling out the x component. We have only the y component, or I can say minus y component or minus j component. So you will answer minus j component, right? It's not correct. In case of a semicircle, what is the direction of electric field? It's only minus j component, because both x components are cancel each other. But in case of a quarter circle, we have a net electric field. We have a net electric field because we have a x electric field will be there, we have a y electric field will be there. Both will contribute and give an electric field that is not in x direction, not in y direction, but between x and y directions. Hope you remember the last sessions. In the last session, sir, we have seen the electric field due to a quarter circle is producing one electric field like this one, which is called Ex, and an electric field is producing in this direction Ey. We have Ex and Ey, and the total electric field we are calculated in these directions. So in case for entrance examination, if they are asking about the direction, then you must have to know the previous things, how we have learned that concept. From there only you will get a clear picture, okay, why I have learned semicircle, why I have learned quarter circle, because there are two intentions. To know these things easier, and the second point is in order to predict the exact directions, because if you go and learn this concept alone, you may not remember what is the direction of electric field for a quarter circle. You may not remember, because here only you will get a y minus y direction, so you will go with the minus y. It's not correct. It's not minus y direction. It will have minus y direction for a quarter circle. It should have a minus x direction, and all together it producing another electric field like this. So there is a combinations are there. So which means the previous session is also important to learn before coming here. These sessions will give you some shortcut methods to find out the answer, but this alone is not sufficient. The other areas are also required, semicircle, quarter circle, then come to learn about arc. That make you to be perfect in this topic. Hope you understood this fourth session also. Still we have a few more things to go, but this is the further things are quite different from what we have learned. Now it is all are connected just like a beads of a chains. Now we have few things which are slightly different, but the same idea, same logic, same concept.